Video, we saw an example of running an async task that returns a result. Once the task was defined, we invoked join to wait for the task to complete, and then we used the method get on the task to get access to the results. Now, upon reading the documentation a bit more, it turns out both join and get mostly serve the same function, that of the main thread waiting for an async task to complete and then get access to results. So let's clean up this code a bit and rely solely on join. And now when we run the program, we get the results. So the join waited for the task to complete and then also gave us the results from the task. Now let's make this interesting. And instead of returning a result, let's throw an exception. And this time, what happens is that the our program crashed. That is because if we look at the documentation of join, it's capable of throwing a completion exception, and this is thrown if the future completed exceptionally, or it threw an exception. So in this case, we are throwing an exception, and the exception simply gets rethrown by join. And so unless we had explicit handling for a runtime exception, our program is going to crash. Um, so this is not ideal. Obviously, we can keep adding try catches around wherever join is called in a task, but there are cleaner, more fluid ways in the API to achieve this. And one such way is the whenComplete, which takes a by function, and the by function gives us access to the result as well as any potential throwable, any exception arising from the task. And so now we are able to handle the exception. Um, so in this case, this if block checks if there are no exceptions, then we can safely print the results. Else, we can have some custom exception handling logic. And now when we run it, the program doesn't blow up anymore because we are safely catching the exception, and then we can have any custom exception handling logic here. So that's it for this video. In the next video, we will look at an alternative to when complete.